Hey, geometry, continuing on with our trapezoids and kites, get into the fewer, weirder things with trapezoids and wrap up with some kites here. All right, so one feature of a trapezoid we have is the mid-segment. Some interesting properties. The mid-segment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So these are my legs, right? We got our bases. If I split those in half, this is our mid-segment. All right, a lot of neat properties here. So the mid-segment of a trapezoid is parallel to each base. All right, so that's going to be one feature of it. And its measure is 1/2 the sum of the lengths of the bases. I think a better way of even saying that, so if you add these two together and divide it by 2, that'll actually give you the length of mid-segment. But really, all this is saying is the average of the bases, or the mean, if you want to be more precise with that. The average of the bases, the length of those two bases. So if BE is the mid-segment of trapezoid ACDF, then AF is parallel to BE, CD is parallel to BE as well, and BE is equal to, and I'm going to write this way, 1/2 of AF plus CD, right? Or you could just say AF plus CD divided by 2. It's the average of those two values. All right, so looking at an example here, in the figure, LH is the mid-segment of trapezoid FGJK. What is the value of X? So we can set up this relationship. We know that this LH, I'm going to write out the formula without any symbols. LH should be the average of these two, so it should be 1/2 of FG plus KJ. All right, so we can plug in what we know and solve for those things. So LH is 15 is equal to 1/2 of FG, I'm going to call X, since they've labeled that as X, plus KJ, 18.2. And now we've got an equation that we can solve. So we multiply both sides by 2, right? So times 2 times 2, so that's 30 is equal to X plus 18.2, right? 1/2 times 2 cancels out. And then we can subtract away that 18, and we get X is 18.2, works out to be 11.8. And so that's what X would be up there for that one. All right, now, and continuing on the back, we've got our last shape here. These are kites. A kite, you can see they kind of look like kites, like you would fly a kite on their page, is a quadrilateral with exactly 2 pairs of consecutive congruent sides. So consecutive congruent sides, not opposite sides are congruent, consecutive congruent sides. And you got to have 2 pairs, not just a single pair, 2 pairs. So consecutive, congruent, 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 congruent. So unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. Make sure when we're doing a kite, we have 2 sets of consecutive. We don't have all 4 sides congruent. We got 2 pairs of consecutive sides specifically. We're not including these in with our parallelograms. If a quadrilateral is a kite, then its diagonals are perpendicular. So we know that BD is perpendicular to AC. So AC perpendicular BD. If a quadrilateral is a kite, then exactly 1 pair of opposite angles is congruent. Exactly. So here we got angle J is congruent to angle L from that. And so it'll be the one that's between the consecutive sides that aren't congruent to each other. Those angles across from each other, opposite angles, will be congruent to each other. All right, so some examples of working with kites. If FGHJ is a kite, then, which we have the consecutive pairs of congruent sides, find the measure of GFJ. So GFJ, that's the one we want to know right there. Well, we know this would be congruent to that. And so we can, I'm going to call this X, and that X, we know that all those add up to 360, and we have a couple of X's. So I can say X plus 128 plus X plus 72 is equal to 360. So we add that all up, we get 2X plus, and then we have all of that adds up to 200 is 360. I probably could have subtracted that all at once. So 2X, subtract 200 from both sides, we get 1 is equal to 160. Divide by 2, X is 80. And so that would be the measure of that angle. So the measure of angle GFJ is equal to 80 degrees. All right, one more example, WXYZ. WXYZ is a kite, find ZY. So we want to know that length right there. All we've got here is some diagonal stuff, but what we can use is knowledge that these are going to be perpendicular. These diagonals are perpendicular. And what we got ourselves here is a good old-fashioned Pythagorean theorem. We got these two sides. It's a right triangle. So 8 squared plus 24 squared equals, and I'll just say zy squared. But you could assign it a variable if you wanted to, zy squared. And so we need to then square both of those. So we get 64 plus that squares to 576 is equal to zy squared. Add them up, and those add up to 640 is equal to zy squared, and then we'll take the square root. Zy is equal to the square root of 640. And so you could solve it like that. That's the square root of 640. We could get the decimal value. Once you type that in. You could also simplify this technically. I'm not too worried about this, but you should technically be able to factor out, especially it's kind of right there in your face, 64 is a perfect square. So we could write this as square root of 64 times the square root of 10, which is 8 root 10. All right, it does simplify to that, but we can also do decimal. I'd probably be okay with any of those. They're all technically correct if I didn't specify one. So there are some kites and a few of those properties.